projects. In this video, we are going to explain about the project title AI-based stroke disease prediction system using ECG and PPG biosignals. Introduction. This project leverages artificial intelligence AI to predict the likelihood of stroke by analyzing ECG, electrocardiogram and PPG photoplethysmogram biosignals. These signals provide essential information about heart health and blood flow patterns, which are directly associated with the risk of stroke. By utilizing AI to interpret these crucial biosignals, the project aims to enhance stroke risk prediction and intervention. Strokes represent a significant global health concern. Earlier detection and timely intervention are crucial to mitigate the impact of strokes. By employing AI to predict stroke risk, this project offers a proactive approach, allowing for timely intervention and preventive measures. This addresses the pressing need for effective stroke risk assessment and management on a global scale. The project's primary focus is to use AI for predicting stroke risk, providing a reliable tool for both medical professionals and individuals. By utilizing this predictive tool, the project aims to guide individuals towards adopting healthier lifestyles, ultimately minimizing the risk of stroke. The integration of AI empowers healthcare by offering a proactive strategy to mitigate stroke risk and improve public health outcomes. Objective. The project's primary aim is to use artificial intelligence AI to predict the likelihood of stroke in individuals. This prediction is based on analyzing biosignals derived from electrocardiogram ECG and photoplethysmogram PPG data. The objective is to develop a reliable predictive model utilizing AI algorithms to assess stroke risk. The project employs a diverse range of AI algorithms including random forest, decision tree, Navy-based, ADA-boost, logistic regression, MLP, ANN, SVM, CNN, LSTM and BiLSTM. Each algorithm is chosen for its unique strengths and capabilities in analyzing and interpreting biosignals. These algorithms analyze the biosignals from ECG and PPG data to identify patterns associated with stroke risk. Through learning from historical data, they can predict stroke risk by recognizing these patterns. This aids in earlier detection of stroke risk, enabling timely interventions and appropriate medical care. The project's ultimate goal is to create a tool that assists both medical professionals and individuals in comprehending stroke risk at earlier stage. By providing this predictive tool, it enables proactive measures and lively modifications to mitigate stroke risk. The overarching objective is to reduce the prevalence and impact of strokes within the population by fostering earlier awareness and intervention. Requirements. The requirements of the project are hardware requirements, in which we have operating system of Windows, processor of Wi-Fi and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements, in which we have Anaconda 3 and Visual Studio Community version. Flow of work. To implement this project, we have designed the following modules. The first module is importing the packages. In this module, the project begins by importing necessary software libraries and packages. These libraries typically include Python modules for data manipulation, machine learning, and data visualization. Importing the right packages is essential to ensure the project can perform tasks like data processing, modeling, and visualization effectively. Exploring the dataset, Ardhimya. This phase involves acquiring and examining the dataset related to arrhythmia, which is a condition affecting the heart's rhythm. Exploratory data analysis (EDA) is performed to understand the dataset structure, contents, and potential challenges. It includes tasks like data loading, data cleaning, and initial data summary statistics. Data processing. Data processing is a critical step where the dataset is prepared for analysis and modeling. This involves tasks like handling missing values, encoding categorical variables, scaling numerical features, and potentially feature engineering. Clean and well-structured data is essential for accurate model training. Visualization using Seaborn and Matplotlib. This module focuses on data visualization. Seaborn and Matplotlib are popular Python libraries for creating various types of visualizations. such as histograms, scatter plots, and heat maps. Visualizations help in understanding data distributions, relationships between variables, and identifying patterns within the dataset, which can be crucial for feature selection and model interpretation. Splitting the data to train and test. Before building predictive models, the dataset is divided into two parts, a training set and a testing set. The training set is used to train the AI models, while the testing set is reserved to evaluate their performance. This ensures that the models can generalize well to new, unseen data and provides a measure of their accuracy. Building the model, in which we have different algorithms. The first algorithm which we have used in this project is random forest. Random forest is an ensemble learning method that constructs a multitude of decision trees during training and outputs the mode of the classes, classification or mean, prediction, regression of individual trees. It's known for its accuracy, robustness, and ability to handle high-dimensional data. Decision tree. A decision tree is a flowchart-like structure where each internal node represents a feature. The branch represents a decision rule and each leaf node represents an outcome. It's an interpretable model often used for classification tasks, making it easier to understand the decision-making process. Navy Bayes. Navy Bayes is a probabilistic classification technique based on Bayes' theorem with the naive assumption of independence between features. It's efficient and works well with high-dimensional data. It's often used to text classification, including in health-related data. AdaBoost classifier. AdaBoost, adaptive boosting, is an ensemble learning technique that combines the predictions of weak learners, usually decision trees, to create a strong learner. It focuses on the misclassified samples, allowing subsequent weak learners to correct those errors, leading to a robust predictive model. Logistic regression. Logistic regression is a statistical model used for binary classification problems. Despite its name, it's used for classification tasks. It estimates the probability that a given input point belongs to a certain class, making it a fundamental model for binary outcome prediction. MLP-ANN, Multi-Layer Perceptron Artificial Neural Network. MLP-ANN is a type of artificial neural network with multiple layers of neurons, often used for complex classification tasks. It's a universal approximator, meaning it can model a wide range of functions. Support vector machine. SVM is a powerful classification algorithm that works well for both linear and non-linear data. It finds a hyperplane that best separates classes in the feature space while maximizing the margin between the classes. Voting classifier. Voting classifier is an ensemble method that combines the predictions of multiple Bayes estimators, classifiers, and predicts the class label based on the majority vote. It can improve model performance and robustness. CNN, Convolutional Neural Network. CNN is a type of deep learning model designed for processing grid-like data, such as images. It uses convolutional layers to automatically and adaptively learn spatial hierarchies of features from the data. CNN plus LSTM, LSTM, BiLSTM, and CNN plus BiLSTM. These are specialized architectures combining convolutional neural networks, CNN, and long short-term memory LSTM or bidirectional LSTM BiLSTM. CNN are effective for feature extraction while LSTM are powerful in handling sequential data. Combining them can capture both spatial and temporal patterns in the data. Training the model. This module involves building a predictive model using the voting classifier technique, which combines the predictions of multiple individual models. The voting classifier aggregates the predictions to improve overall accuracy compared to individual models. This step is crucial for enhancing the reliability and accuracy of stroke risk prediction. Building the model with voting classifier, since it gives better accuracy comparing with other models. Flash framework with SQLite for sign-up and sign-in. In this module, the Flash web framework is utilized to develop the application. Flask is a lightweight and efficient Python web framework used for building web applications. SQLite, a lightweight database engine, is used for user authentication, sign up and sign in within the application. Users can create accounts, log in and access the prediction features through the system. User gives input as feature values. This module focuses on the user interface where users input their feature values relevant to ECG and PPG biosignals. These feature values are then pre-processed to align with the format expected by the trained model. Pre-processing may involve scaling, encoding, or any necessary transformations to ensure that the input is in the correct form for prediction. The given input is pre-processed for prediction. Trained model is used for prediction. Once the user inputs are pre-processed, the trained model voting classifier in this case is utilized for prediction. The pre-processed input is fed into the model and the model predicts the stroke risk based on the input features and the patterns learning during training. Final outcome is displayed through front end. After prediction, the final outcome, typically the predicted stroke risk or a relevant output, is displayed to the user through the front end of the application. This could be presented as a risk score, probability, or a categorical label indicating the likelihood of a stroke. Providing a clear and understandable outcome is crucial for the user to interpret the prediction. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database and generating dynamic content to be rendered in the HTML templates. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is model file which contains algorithm information which will be loaded into the project code during runtime. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the folder from the address bar of the file explorer. I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. I am typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flash framework will host the application locally at the default address, which is this, and port, which is this. Now copy this local link. I'm copying the link. And paste this copied link into any web browser. I usually prefer Google Chrome. And hit enter. The home page of the project is displayed in the browser. This is the front end built using Flash framework. Now click on sign up button. If we are a new user, we need to register first, but I have already registered, so click on sign in button. This is the login form. Here we need to enter the username and the password which we have created. So I'm entering the username and the password and click on submit. This is the home page of the project. So here we need to enter all these details to predict whether the patient is having stroke disease or not based on ECG and PPG feature values. So I'm entering these details. So here I have entered all the details. The age is 75. it is a female, and the height of the person is 190, weight is 80, and QRS duration is 91, PR interval is 193, QT interval is 371, value of T interval is 171, P interval is -16, P interval is 121, QRS is -16, Q wave is 0, R wave is 52, S wave is 44, R dash wave is 0, S dash wave is 0, AA wave is 32, AB wave is 0, AC wave 0, AD wave 0, AE wave 0, AF wave 0, AG wave is also 0, and the AH wave is also 0, and the value of AI wave is 44 and the value of LG wave is 50. After entering all these details, we need to click on submit. Here the QRS is the combination of the Q wave, R wave and S wave, and QRS complex represents ventricular the polarization. So now click on submit to predict whether the patient is having the stroke disease or not. So here we can see we got the outcome. Diagnosis has stroke disease based on ECG and PPG feature values. So here we can see that this person is having the stroke disease based on the ECG and PPG feature values which we have entered just now. We will enter one more patient details and find out whether that patient is having the stroke or not. So I'm entering the details. So here I have entered all the details. The age of the person is 55 and she's a female. Height is 175, weight is 94, and the rest of the details I have entered. Now click on submit to find whether the person is having the stroke or not. So here we can see not diagnosis has stroke disease based on ECG and PPG feature values. So we can see that this person is not having the stroke disease. So in this way, by entering the ECG and PPG feature values, we can predict whether the person is having the stroke disease or not. Now click on sign out, and the conclusion of the project is the project employs a variety of AI algorithms, including advanced models like convolutional neural network CNN, long short-term memory LSTM, and a voting classifier ensemble. These models are trained to predict stroke risk by analyzing the ECG and PPG biosignals. The voting classifier extension is particularly noteworthy as it combines predictions from multiple models, enhancing accuracy and providing a robust tool for risk assessment. The project utilizes Flask, a web framework, to create an interactive platform where users can input their feature values related to ECG and PPG biosignals. Once the user provides these inputs, the trained model processes the data. This user-friendly interface enables not only medical professionals but also individuals to receive predictions about their stroke risk. It promotes informed decision-making regarding potential stroke risk based on the provided data. The main objective of the project is to enhance public health by focusing on prevention and earlier action in relation to stroke risk. The predictive system, powered by AI models, is designed to identify stroke risk early on. This earlier detection encourages individuals to make healthier lifestyle choices and seek timely medical care, ultimately leading to better health outcomes and a reduction in the overall impact of strokes on public health.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.